In this video, we're going to start doing the object-oriented programming about classes, constructors, attributes, and methods in Python. So the first is the objective of this class. We're going to create classes to define objects and write methods and create attributes for objects. And then we're going to create objects from the classes, and then actually access the attributes and the methods. So let's first talk about what is object-oriented programming. Object-oriented programming is one of the methodologies that we use to write the programs. In the past, people use sequential programming. So they treat every task as a ordered instructions. Well, the object-oriented programming, or OOP, actually treat everything as an object. And inside the object, you have data and methods. So you have the data, you have the actions on those data. So for example, you can calculate something to those data. So it's a new methodology to actually solve the problems, and turns out OOP has much better. I will say OOP actually has a lot of benefits over the sequential programming. So for example, OOP, it's a lot easier to actually maintain the code because you have the abstraction of the objects of the classes, and then you have encapsulation, you have polymorphism of the OOP, and so those are the ones that make the programming a lot cleaner and logical wise, and also it's easier to maintain, it's easier to test. So that's why now OOP becomes one of the major methodology used in the programming. So first of all, let's understand the basics concepts of the object-oriented programming. So OOP allows the representation of real-time objects. For example, a pen, or a computer, or a figure, or a weapon. Everything you can see in the everyday life, it can be an object. So object actually is a single software units that has a combination of attributes and methods. Basically, is the data and the functions or the actions to those data. So attributes are normally is called the properties of the objects. For example, a dog, it has a color, has the size, has the weight, has the breed. Those are all the attributes of an object. Some people call it the properties. There are different terms, but basically they mean the same thing. It's the data associated with that object. Well, methods are basically the behavior or the action of the object. Like a dog, they can walk or run, can bark, can eat, right? Those are the actions of the object or behavior of the object. Or sometimes when we're dealing with the other things like a random number. For random number, we probably can do the calculation. We can get a random integer, things like that. Those are the actions, right? For classes, the classes will be actually the code. You can understand the classes are not the actual object. You can grab, you can fill it. Well, classes are like the rules or the code that defines the objects and the methods. It's like the law. So that's the differences. Classes are the abstract concept of objects. Well, objects are actually the things that you can touch, you can feel, you can work with. So that's the differences. And the fundamental concepts of OOP is so information is hiding inside a class or inside an object. So it's abstraction. So all the same type of objects is sharing the same properties, same attributes, share the same methods, and its encapsulation means we put everything inside a class. We don't interfere with other classes. And modularity, that means we put every related things in one module. So encapsulation is for a particular class, while modularization is it's a little bit bigger. Could be multiple files, multiple classes in one module. Polymorphism means you can actually have one parent class and it can refer to multiple child classes as long as they are the same family. Inheritance means we can define a base class or parent class, then the child classes will automatically inherit almost all the methods or the actions of the parent class. Sometimes if the attributes are in the right type, it can be inherited as well. So those are the basics. Again, those concepts itself can be a like object-oriented programming itself can have a whole class. But here we are just introduce the basics. And creating a class for an object, we can first have to use the class as a keyword to indicate this is a class. Well, then we're going to put the class name and then the object of the class. And then we can define the initial, which is it's like a constructor. So the class actually is defined the attributes. You're going to have attributes and the methods. Okay, the instantiation it's going to create an object. How are we going to create an object? Normally it's under this initiation. So your other classes are called constructor, but here you are going to use underscore then init underscore. So that's your constructor. Then you have self, and then self must always be there. And then you have the name and the color. Those are actually the attributes. So you have self.name, self.color. So that will actually becomes the attributes of this puppy class. And then you can have methods, like define and methods. A method is actually a action that this puppy will do. So inside the parentheses, if you don't have any other parameters, you will have to put self in there, so you can reference them. So print im, then color and name, so you can print that. The simple creator program, for example, I have a creator program, and then I can have define the talk. It's going to be self, and then we can start to doing something, some actions. In this define of the class, we didn't have the init. Init there will have a default init for you. If you don't want to initialize any properties, any attributes, it will be skipped. However, inside the Python actually did that for you. So here we actually need a creator, and you can do creator.talk. Same thing here, puppy, we actually construct a new object, and then you can refer in the methods inside the class. So that's the method you are referring it. And the class method and the self parameters, the class method, it's pretty much like functions that we learned. However, those functions are must associated with inside the class. So you don't give a value to this parameter like self, because that's basically is the object itself. It is a particular variable referred to the object itself, and by convention it gives the name of self. It just happen to be self name, but it's a reference to the object itself. So how do you actually create an object? You can simply just use the class name, then add the parentheses. If there is no parameter, you just do that. It will create an object. And then you can create multiple objects. Each of them is going to receive a new piece of memory, so they're not interfering with each other. And when you invoke the classes, when you invoke the methods inside the class, you can directly use the dot, then talk, and then actually the method's name. You can do the reference of the or in call the methods or invoke the methods. Okay, the constructor is a special methods that will help to initialize some values of the attributes. Sometimes you gotta do some operations. It can be done inside the constructor as well. It's usually set up the initial attributes. So the constructor actually has a special name. It's underscore init underscore then self. So this is the default one. If you don't do this, the Python, like I said, it will do this for you. So this is another example of the constructor that initialize attributes. You can access the attributes once it's set there. You can directly access create one.name. That's actually you are referring the attributes of the class of the object, and it's just same thing as you are referring the methods inside the class. However, method has the parentheses. That's actually differentiated. This is the attributes, this is the method, because you have the parentheses. And printing an object. How do we print an object? We can actually directly print the object itself. It's gonna give you the str. It will call the str methods. This is it's like a toString in other programming language, like in Java. They have for every object they have a default methods called toString. Here we just simply use underscore str__. That's the same thing. So if you want some information to be printed, you can use this. And the two most special methods. We know this is init is the constructor, and we can do get item and set item. So this is set the new values or update the values of attributes, and then get items is actually accessor of those properties. You can access some of the values. For example, you can get the item from the color, right? You get one, you get the other ones. Use the class attributes and static methods. Sometimes we want to use the attributes, a single attributes that is associated with the class itself. We call it a class attributes. Well, static method is a method that associated with the class itself. You don't have to construct an object to actually access the static to access the method. So, for example, we can create a class object, class attributes. I can have a class, and then this is the definition. Then I have a class attributes. This one creates attributes total and set as 0. So in the future, if I want to refer in this one, I can just use the object and then total. That will be able to, this will be able to access this total variable. And remember, this is called the initialization of the class attributes, and this only execute when this object is created. So it will only execute once. And here's example. So now I have a class creator, and then I can directly referring the creator.total, and then I cannot just operate it. We cannot operate it. And then once I make an object, then I can access the total. Keep in mind, even you have object, you cannot directly operate. This is attributes is more like you can access it, you can read it, you cannot update it. So create a static method. For static method, you will have to, for example, we have the define a status. A status is a static method, does not have the self in it, so there's no self in it, so it's be treated as a static. In other programming language, it will normally put a static in front to differentiate. But Python is a kind of special. They don't put that way. It's just put a static. It's just do not include the self as a parameter. So it will be treated as a static. Invoke the static method. You can directly invoke it. You don't have to add anything. You can directly put the other parameters. That's how do you do that. In this case, in our case, status does not have any parameter, so we can directly use it. You don't have to create an object to be able to access the static methods. We can set some default values. So after the self, we can set a default value as Tom equals this and age equals this. So in the future, if you just make an object, you're going to have the default value of the Tom and 20 as the name and age. Here is basically the summary of this lecture. It's just introduced some basic concepts of object-oriented programming. OOP is actually a methodology of programming. So all the things are treated as objects, and the objects are actually the piece of memory allocated according to the class. The class is actually the code, the rules of abstract objects. So it spells how the attributes will be defined, how the methods will be defined. And then the Python is going to allocate a piece of memory and initialize the memory with follow the rules that defined in the class and define that object, and then you can use it. So the attributes are actually some properties or characteristics of an object, while the method is actually a behavior of an object. And the class defines the attributes and method of an object. And normally it's an abstract class as a abstraction, the common things among a bunch of objects. So when we create an class, then we can use the constructor to create an object. And when we want to print the class, we are going to use str as a method, and the class attributes is actually the single attributes that associated with the class itself. Again, you don't have to make an object to access. You can direct access. However, the initiation only execute once. All right, that's the end of the this part for the OOP.